Well, hello everyone, and welcome to Building a PCI Environment using Serverless. My name is Micah Hodge, and I'm a Senior Manager of Software Engineering at a company based right here in Nashville called Asurion. And today, thank you for the clap. Woo! Yeah. So today I'm going to be going through and telling the story and sharing some of the lessons learned from taking one of our legacy PCI applications and migrating that to AWS Serverless. Now, just a little bit about me before we get started. As I mentioned, I work for a company called Asurion. If you haven't heard of us, we're best known for our cell phone insurance, but we actually have a whole bunch of other offerings in different retail spaces, as well as device repair and tech support. So I would encourage you to check us out online if you feel like it. My responsibilities at Asurion include some application development, one of those apps I'm here talking about today. My teams also do a lot of CI/CD and cloud tooling, so entire CI/CD pipelines, but also reusable frameworks and code bases for other teams to use, and then also the underlying platforms that facilitate all of that. I do own release management for our mobile claims systems, and then I spend a good deal of time functioning as a consultant for different Asurion projects all over the globe, helping people improve their cloud CI/CD, DevOps methodologies, etc. All right, moving into the agenda, we're going to start today with some expectations and basic terminology. We're not going to go super in-depth on terminology. It's really just going to be to make sure that everyone in the room has a rough idea of a simplified serverless architecture. We'll talk about what happens when you decide to put PCI data in the cloud. And then we'll go over some of our standards for both PCI and infrastructure security. We'll also do our best practices for data management. We'll talk about PCI and PII there. And then we're actually going to spend some time talking about resiliency, which is something that I get really excited about. So this is almost an entirely separate talk, resiliency, but it is an integral part of this story. So we'll share our multi-region architecture with you and our automatic failover system. For anybody that's looking to do something like that, I'll show you exactly how we do it. And then we'll do some tips and finally some Q&A. All right, so expectations, a heads up, this is going to heavily focus on AWS, okay? But it should be applicable, all of the approaches should still be applicable to any cloud provider you choose. So if you're in Google Cloud or Microsoft Azure, just do the translations and tooling wherever you see fit. But all of the approaches should still be relevant. Expectations for you, so if you're a novice and you're pretty new to AWS and serverless, you're going to gain at least a rough understanding of a serverless architecture. You'll also get an introduction to how we handle some of our cloud security practices, and you'll get some helpful tips for getting started. Now, if you're an expert and you already know most of this stuff, hopefully you gain some insight by seeing how we operate. Maybe it reaffirms some of your decisions or gives you some new ideas. And you'll get some shared wisdom through our lessons learned, and I promise I'll share at least one of our failures too. And then if you're in between, you've got the most to gain. You're going to get everything above, but you're also going to get reproducible implementation walkthroughs. And what I mean by that is there are times where this will remain a little bit conceptual. You know, how do we create standards, enforce standards, et cetera. But I have made sure to go ahead and include some diagrams and implementations that you could take home and implement yourself if you want. All right, so moving into our basic terminology, this is a very simplified serverless architecture. I'll step through these components pretty briefly. But our users first connect to CloudFront, which functions as our CDN. It serves all of our edge content to our end users. And CloudFront allows us to register different origins underneath it to do things like route to our static UI content or to our backend services tier. Now, the first origin we'll talk about is our S3 bucket. That's been mentioned previously at the conference. It's just an object storage bucket. You can put pretty much anything that you like in S3. But for the purpose of this diagram, we're putting our static UI content there to serve our JavaScript through CloudFront to our end users. The next origin's API gateway. You can actually expose this separately without using CloudFront. However, we've chosen to unify our domain in this example. And CloudFront does a lot of things, but we'll summarize it by saying that it provides pathing to our backend Lambda functions. And then I'm assuming that most people in the room have at least heard of Lambda. It's just an ephemeral stateless microservice. It's a little floating function in the cloud that exists when you need it, doesn't when you don't. They're pretty great. And some of those may or may not connect to our backend database, which is DynamoDB. It's just a serverless document database. Now, I do want to go ahead and call out, please do remember the S3 bucket, because that's going to get very relevant here in just a second. And now that we have some of the formalities out of the way, would anybody like to get us started by taking a guess as to what happens when you tell your colleagues that you would like to put a PCI app in the cloud for the first time? That's a good guess. They freak out. okay? So this started for me with a legacy application, and this app was in scope for PCI data. And because it was in scope for PCI, it had always been hosted on premises. So we actually had a whole bunch of stuff in AWS at the time. This was a couple years ago. But we hadn't moved our PCI app to the cloud. And it being on premises and an application with sensitive data, it was just kept in an enclave. We had a whole bunch of firewalls in front of it. And it was just really private, right? Like that's the way security had been done for years. And me coming in and talking about taking this very private app and moving that into the public cloud definitely made some people uncomfortable, as it probably should. All right, so I did immediately get very busy. I had a whole lot of meetings added to my calendar, and I started to meet a lot of interesting people from compliance and security that I didn't really know as well before. And actually, some of those individuals definitely thought that what I was doing was either dangerous or negligent or both. And that's really okay. I mean, I think that we shouldn't take this lightly. This is something that if we don't do correctly, will introduce a whole lot of risk to our company and to our customers. And there's a growing list that's growing almost by the week of companies that fail doing exactly this. So I have pulled some examples of some recently leaked data for you. This is all leaks from the cloud. And this isn't an all-inclusive list. I just cherry-picked a few out that I found interesting. So we've got things like Pentagon spy archives, which was the operations history and resumes of US intelligence personnel. We've got the PII of millions of WWE fans. So if anybody in the audience is a big wrestling fan, for starters, your secret might be out, okay? But also a lot of your own personal data, including the age ranges of your children. We've got PII from telecom and cable providers, even battlefield satellite login credentials and US voter records. So I show you this list to say that this doesn't affect just a small subset of cloud practitioners, right? This is an issue that we see across different organizations and across different types of data. We've got representation from the entertainment industry here. We've got media conglomerates and even the US government. So when you hear about this so often and frequently, it ingrains in us that maybe the cloud isn't like a safe place for this data, right? Maybe it shouldn't go there. Until you consider that through 2025, 99% of cloud security failures are expected to be the customer's fault. And by the way, the customer's all of us, in case that was a little bit open-ended. So if we stop and think about this, and we say, well, if it's our fault, that means it's not AWS's fault, and it's not Microsoft's fault, and it's not Google's fault, but they're certifying these things as PCI DSS compliant in many cases. They're saying that the tools exist to do this, right? There is a safe way to do it. And another way to say that is that this actually isn't much of a technology problem whatsoever. This is mostly a process problem. In fact, all of the leaks that I just showed you were due to poorly configured S3 buckets, which was the object storage bucket in the terminology section. And the difference between a safe and unsafe S3 bucket many times is just a checkbox, right, in the AWS console. So the message is that it's easy for people to make mistakes, and that we have to empower our resources so they make fewer mistakes, but also have processes that protect them and the company when they inevitably screw something up. All right, so we want to solve this problem, but first we need to understand a little bit about how companies go wrong here, because there are some behaviors that we just can't fall into. And I'm going to step through these kind of briefly, and then I'll talk about how we've addressed each one of these at Asurion. So the first is a lack of preparation and not having well-defined standards. Obviously, you need to take time and effort to create good standards. When I was working with my security team, it did seem as though this was one of their big concerns. And it wasn't so much that they didn't think they could create proper standards, but did my plan involve their participation? Was I going to work with them? So just if you find yourself in this predicament, make sure your intentions are fairly upfront and really dedicate time and effort into working on your standards. We also have to worry about things like a lack of accountability, and just a heads up that accountability is really hard, right? It's driven by process, but it has to create a culture of accountability. And I would assume that most, if not all, of the companies in those leaks probably had it written down somewhere that you shouldn't take your most private content, put it in an S3 bucket, and then expose that to the world, right? If you ask people there, they probably considered that a generally bad idea. And then we also have to worry about a lack of understanding, and this goes back to the individual. And this happens to be the fuel for most of the poor configurations and security gaps that we see in the cloud. And when you ask people why they did these things, they inevitably say things like, oh, I didn't know that was public, or I didn't understand what that meant. Or my favorite that I used to hear all the time is, I was just testing, right? I'm sure everybody in this room has heard that that's worked in the cloud. So we have to empower our users so that they understand enough to not make the same mistakes. Okay, so first thing, we had to create PCI standards. So we immediately created some separate AWS accounts specifically for PCI. We actually have a whole bunch of AWS accounts at Asurion, but we took a couple and created them specifically for PCI apps, and they have a little bit of extra scrutiny. To get into these accounts, we said you're going to have to use privileged user accounts, so you can't just log into these with the same things that you would use to log into your desktop or even to another AWS account. And then we've heavily limited peering and connections to all other VPCs and networks. So this is pretty straightforward, right? And we actually do this for all of our accounts, but we have extra approvals and layers there that stop us from poking holes in this firewall. We've also imposed some very strict encryption requirements on all of our sensitive data. And I'll get into that in just a second when we cover data management. And then we've heavily reduced all of our actions to the console. So to do a deployment, troubleshoot an issue, what have you, I have really no need to log into the AWS console. And this is really important because it's not just good practice. It also gives me an auditable log of every single change that's ever entered this environment. And I can tie that back to a Git commit history and a username and a commit message and probably even a Jira ticket to find out what the business need was. All right, so now we have to think about how we can drive accountability. And I do want to do a quick call out that everything I just talked about in terms of standards, that's pretty PCI specific, but these other things are things that you should just do regardless. These are good practices in the cloud, and these were things that we were doing well before we introduced any PCI applications into our cloud. So for starters, it's going to be next to impossible to have a safe and secure cloud presence at an enterprise scale without centralized governance. Right? We need people that focus on sustaining, standardizing, and improving our cloud posture. So at Asurion, we actually have a group called the Cloud Governance Team. Guess what they do? Okay, they actually do a whole bunch of stuff, from account creation and maintenance to custom tooling for things like cost optimization and reporting. They have Slack channels that we're constantly in. They're forums for communication. But I did want to come and talk to you about some things that they do specifically for accountability. And the first is they've created this very clear sense of ownership. So in our cloud, if you do not, or in AWS, it's not ours, if you do not specify tags that say who this belongs to, who created it, what its purpose is, how do we bill it, there's a bunch of criteria, then it just gets deleted, okay? Non-prod production doesn't matter, it's going to go away. And this is really important because when we start talking about detecting issues within our cloud, we have to know who to go follow up with, who to make sure that we hold accountable. They also do constant engagement, not just with project teams like myself, but they're also working with operational teams as well as AWS account teams. So we all stay engaged. We find out what's new, what's coming in, what kind of problems are people hitting. And they also go through a lot of their own data. They have tons of data that they're constantly combing through, looking for patterns and problems in the environment. And then finally, the most important thing in my opinion here is monitoring and scanning. When I go talk to my cloud governance team, they're actually scanning. Their rule set's in the hundreds, right? But I have simplified some so that I could share them with you all. So we scan for things like publicly exposed resources. So there's no reason that anyone on my team should actually have a public S3 bucket. So if one's detected, I want it auto-remediated. I want a notification sent to me and to cloud governance, right? So we're catching things before they become a problem like we saw in those leaks. We also scan for things like over-permissive IAM policies. This gets really important when we're talking about least privilege. And then we look at insecure TLS configuration. So if we're trying to remain in a certain level of compliance with, say, PCI, we have to ensure that we're not running insecure TLS policies. And then we even look at changes to security groups. So I can tag my security groups with just a tag that lets them know, hey, if anybody edits this, send a notification to the team that owns it and to yourself. Because my security groups shouldn't change all that frequently. So if somebody's changing them, there is a potential that it could be something nefarious. All right, so now we're going to talk about how we've worked to make information a little bit more readily available to everyone at Asurion. And there are the obvious things that we do, like push for the standard certifications, right? We always have people getting AWS certifications. But we have a special program at Asurion that we call the Security Mavens that I wanted to talk to you about. And the security mavens are made up of representatives from teams all over the company. And you're put up by your management, and there's actually an interview and approval process. And if you're accepted into the Security Maven program, you're going to go for in-depth security training over the course of weeks. Okay? And you're going to come out a subject matter expert in all things security. It's not just AWS, it's really across the board. And it is your job to go back to your respective team and propagate not only the information that you've learned, but also the security-first mindset. And that mindset is really just the acknowledgement that security is something that we all have to care about. Right? Security isn't something for someone on a security team or even just for the security maven to care about. If you're working at Asurion, we actually have an expectation that you're going to have security in your forethought at all times. And this also does provide a good amount of oversight and support by having a network of highly engaged subject matter experts. So if I don't have a security maven on my team, I at least know someone who's a security maven. There is an expectation that we're going to do this, and then we supply the network and the subject matter experts to fulfill that. And then finally, I've listed automation here. So automation is something that I harp on all the time. Anybody who knows me knows this. Automation not only makes safe implementations reusable, right? I write it once, I reuse it, but it's also a great learning device for people that don't enjoy learning conceptually. And what I mean by that is it's one thing to explain to somebody how an IAM policy affects a Lambda function, maybe clicking through a console. It actually can solidify people's understanding to look at good declarative infrastructure as code. It can help you standardize and actually push those same concepts much further. All right, so now we're going to talk about how we secure all this infrastructure. And if you think there's not infrastructure, you're wrong. It's just different, okay? Now, there are obvious things that I felt like I just had to call out, like endpoint protections, things like custom authorizers or Lambda authorizers. It's just a Lambda function. You can attach your API gateway endpoints to do things like token validation, and there's some nice caching and other features. But you should also, of course, be putting WAF and Shield on all of your publicly exposed resources, not just CloudFront, but API gateway should have regional WAFs on top of that. And the real purpose of this, though, is to talk to you about least privilege. And least privilege is just starting with 0 permissions on all of your policies and slowly incrementing very explicit permissions until you have exactly what you need. Not the other way around where you open up a bunch of permissions and then file them down. That never works. Okay? And we also have to make sure that we're doing this in a very granular way. So you can't just create an IAM policy and attach it to all of your Lambda functions. The rule here is you should probably be creating an IAM policy for each of your Lambda functions. And if you happen to be using deployment tools such as Serverless Framework, there's open source plugins out there that you can download and use to actually build IAM policies very easily for each of your Lambda functions, where you just say, like, hey, this Lambda, right in the declaration of it, needs put permissions on such and such DynamoDB table. And then that framework will actually build and maintain all of your IAM policies for you. You should also do things like alert on unused permissions. So another function of my cloud governance team is I will occasionally get a notification that says, hey, team, you've only used 3 out of the declared 5 permissions for this IAM policy over the last 30 days. You know, what gives? And that's a really great notification to get, because not only is it hard to argue with what's actually in use within my environment, but it's usually a really great indicator that I've gone somewhere wrong with my least privilege. And then you should also fight promiscuous security policies. So I can guarantee you that you will see these things, okay? You will see things like completely empty CIDR blocks opening up traffic from any IP address. You will see things like star permissions that allow you to do whatever you want to any resource in any account. And people always kind of claim that they were testing, again, right? And when I stop and think about it and I go, well, if you're testing by changing firewall rules, what are you testing? You're testing AWS's firewall for them. Don't test AWS's firewall. AWS has people that test their firewall. So this actually goes back to a lack of understanding. So if somebody's opening up a CIDR block with an empty CIDR block like this and allowing access, they probably don't understand the connectivity between their 2 resources. And if they're opening up an IAM policy too wide, they either haven't taken the time to understand what that service is doing, or it could be a heads up that the service is too big. If you can't easily identify the purpose and permissions needed for a service, consider breaking that up into smaller pieces. And then a call out that IAM roles and security groups comprise the vast majority of serverless infrastructure security. And this is actually great news because, again, this means that all of the tools were provided for you. We just have to use them. So take some of that time that you were going to spend coming up with a patching cycle or discussing sudoers permissions or whatever it is, and instead teach people to write good IAM policies. Okay, so now I'm going to tell you how we manage all of this data, and we'll start with PCI. So for our PCI data, we actually embed a public key into the browser, into the client browser, and we encrypt all of our PCI data in the browser prior to it ever being uploaded to AWS. And then once the AWS account receives that the encrypted fields, it not only doesn't store the key within it to decrypt that data, but it also has no access to do it whatsoever. So this account cannot decrypt any PCI data, which means that for some reason, should you be able to come in and compromise our account, you're still not going to see a single credit card. Right? Simple enough, right? It's just used for storage, okay? All right, now for PII data, we actually have a little bit of a different setup because we have a need to actually decrypt the data within the account. So we use a service called KMS. It's just Key Management Service. And we are able to call this service from a Lambda and pass the ARN or the identifier for a key to use, and it will automatically pull the key and execute the encryption or decryption. But we actually don't store any of our KMS keys within our account. So we have a separate account that was built and maintained by the security teams, and it's a key storage account. All they do in that account is create keys, and then they specify using key grants what we can pull, and we pull it at runtime. So we call KMS, pass the identifier. It's going to, on the back end, go to the other account, ensure we have permissions to pull it, execute our encryption or decryption, and then throw the key away. So we never get to store that key within our account. And this is good because it provides that extra layer of abstraction so you can't just log into our account, start looking at our KMS keys, trying to match that up with data, right? There's a whole lot more to it. It's going to be a lot more difficult to reverse engineer. Okay, so now for something I get super excited about, resiliency. And resiliency changes a lot from that of a traditional compute model. So in a traditional model, we cared about things like how many servers did we have in a cluster, and could we scale up and down with customer load? How were those events configured? And occasionally, we even had to worry about things like, is my application stateless enough that I can lose an instance of this without affecting my end consumer? And with serverless, that all goes away, right? AWS handles our scaling for us. It doesn't use metrics. It's all event-based, which is great. And Lambda is inherently stateless, so we don't have to worry about that. But it doesn't mean we're actually out of the woods entirely. Because just as we no longer have to care about those things, we lose a little bit of a luxury in that we no longer put everything a service needs into a single jar file or to a Tomcat process or even a container. We now most likely have dependencies that are distributed across the AWS ecosystem. And each of those dependencies has the possibility of going down or becoming unavailable at any time. So to me, resiliency partially means preparing for systemic outages in distributed cloud offerings. And my team has chosen to mitigate this by implementing a multi-region architecture. And this works because AWS is very good at compartmentalizing updates to specific regions at a time. So if they're changing underlying compute resources or they're rolling an update to a product, that most likely only occurs in one region at a time, so any subsequent outage from those actions won't occur in two regions simultaneously. Now, we also have to think about how resiliency changes our code and our architecture. So obviously, a multi-region architecture, that's going to affect our architecture. But we also have to consider that we now replace a lot of what used to be boilerplate code with very opinionated resources from AWS. And each of those opinionated resources has built-in behaviors that we have to account for. So if I start building something, I can no longer just write code and operationalize it later. Those behaviors have to be thought up at the time of conception. So that's really important. You have to start thinking about these implementations way ahead of kind of a traditional development approach. And then it's also going to change your code, and I'm not just referring to really important things like retry, exponential backoff, dead letter queues. It might actually change the actual packages that you use, because, for instance, KMS doesn't work in 2 regions at the same time. So you have to use an encryption SDK written by AWS so that you can pass both keys in during encryption and then use either region's key to decrypt, right? So it's important to know that it is going to affect your code. You're going to have to write in some resiliency, and it might even affect the packages that you use. Now, finally, I want to harp on this. You need to ensure that you understand all of the application dependencies and their respective SLAs. And the way I'll sum that up is by saying that distributed applications mean distributed dependencies. So think about that I no longer have the ability. If KMS goes away, what happens to my service? And a way that I'll clarify that for you is with something that I call the rule of compounding unavailability. And full disclosure, this is absolutely meant to scare you. This is not going to be anyone's experience in AWS whatsoever, but I do want to show you the hypothetical mathematical maximum for what you're signing up for when you use these services. All right, this is more of a thought exercise to have you think about this. It's not really meant to scare you away from serverless. AWS is better at this than we are. That's why we pay them. But so if we take CloudFront, API Gateway, Lambda, and KMS, and this would be an example of a very simple service, okay? If you're using KMS, you're probably also using something like SSM for parameter storage. You might also be using DynamoDB or something else. But let's just take these 4, and let's compound the availabilities, because all of these are required to make an individual service work. And we get a combined availability of 99.7, which comes out to a little bit over 2 hours of outage a month, which I'm pretty sure would violate everyone's SLA in this room, okay? So again, not going to be your experience, but the message is that you're going to have to come up with your own availability and promise that to your business and to your customers. And you're going to have to find your own comfort level with what that is. And for me, I mean, you'll see great availability in a single region. But for me, I want to go multi-region because I want my availability to go from really good to being great. All right, so now I'm going to show you how we actually manage our service routing and our health. So what we did was we got a few of us into a room, and we just started whiteboarding different possibilities. And we came up with a series of health checks that will help us determine the individual health of any given region and then automatically trigger that failover. So the first thing we did was we exposed region-specific endpoints that we could consume with different cloud-native health checks. And we did that because we used to see this a little bit more. We don't see it as much lately. But we used to see issues of 4 or 5 minutes when API Gateway just couldn't talk to Lambda. So we said, all right, let's expose a Region 1 health endpoint, a Region 2 health endpoint, and both of those, for those respective regions, will map from CloudFront to API Gateway to Lambda, and we'll just send back a dummy 200. You can send back anything, right? And so we're able to do that point-to-point connectivity check to verify that all of those services are able to talk to each other. And we said, okay, well, we need to consume internal and external health checks. So if it's external, we'll use Route 53. Route 53 is just DNS, okay, but it also has a health check system built into it. And if it's internal, we'll just write a Lambda. Let's use serverless to monitor our serverless. And then we said, well, it's not just enough to verify point-to-point connectivity. We need to verify our individual application dependencies. And so just as we can write a Lambda to ping an endpoint, we can also write a Lambda to scan a DynamoDB table or touch an S3 bucket or call KMS or whatever that is, right? So here is a diagram of our point-to-point connectivity health check. You can see, I'll trace this in blue in the Region 1 health check. You can see we expose through CloudFront our Region 1 health endpoint. That registers to Region 1 API Gateway. And then subsequently, like all of the subsequent resources within that region. So Lambda, DynamoDB, what have you. And then you'll see our production traffic shown here in green. And we use Route 53 to resolve to CloudFront. And then from CloudFront, we resolve using a primary Route 53 record to our Region 1 API Gateway. Now, if we detect an issue in Region 1 health, we'll automatically fail over using a failover routing policy and another Route 53 to automatically resolve to Region 2. Now, I'll show you exactly how that works. We start with a top-level Route 53 health check, and all it does is watches a bunch of child health checks. And I have 3 categories that we've come up with here for different types of health check. This isn't just 3 health checks. There's a lot more than that, but we have 3 categories. The first is endpoint validation. That's the point-to-point connectivity check that I just showed you. We also look at CloudWatch metrics, so this could be things like error rates or whatever information you're piping in CloudWatch that you want to look at. And then custom Lambda. This technically goes through CloudWatch too, but ignore that. Okay? And so Lambda, again, that's doing things like scanning a DynamoDB table. And one important call out here is that you're looking for systemic outages. So this doesn't actually have to be your production DynamoDB table. This has to be a DynamoDB table in that same region. And if any one of these goes bad, then the top level health check fails over and our DNS just flips. And then we're in region 2, serving out of region 2. Okay, so it's time for production launch. We feel super great about all of our security, all of our standards and practices. We also feel really good about all of our resiliency, right? We're going to fail over if there's any issues. So I'm super proud to say that we've never hit any issues and it's been perfect. Except I'm just kidding, everything broke. Okay. So I do remember I was driving home from work and I got a phone call from someone at the office and they said, Micah, you're not going to believe this. We're seeing Lambda duration alarms, we're seeing some errors, and nothing happened. It's like we didn't fail over. And so they said, I don't know what to do. And I said, okay, fail it over, manually change DNS, and then we'll open up an incident and we'll take a look. And so we failed it over and everything just started working. And that was a little bit bittersweet because we were happy to restore service, but it meant that we missed something. And so when we investigated, we found that we were writing to Kinesis for some critical analytics operations, and Kinesis just became unresponsive. And we didn't have a default timeout configured in the AWS SDK, which, if I need to tell you, that's a really bad idea. Okay. So that told us a couple things. One, let's add a timeout. Secondly, let's probably add something to look at Kinesis specifically. But we also need to provide what we call catch-all alarms. And these are alarms that aren't really tied to a specific dependency. It's not enough to just look at your dependencies. We also need to verify the behaviors that we see during outages. We need to look out for those. So we had our Lambda duration alarms. They were already going off. We were smart enough to do that. We just weren't smart enough to wire them up to our actual failover. And then now we're going to fail fast because we added this timeout, right? So we should be looking at error rates. And then if we hit a certain number of errors, or a certain rate of errors, I should say, we should automatically fail over based on that. And then this is actually a visualization of the specific failover event. So this is a Kibana representation. You'll see us doing our blue-green deployments right there, and then that dark blue into light blue is the actual failover event that we had to trigger manually. Okay, so finally, I'll leave you with some tips. These are just some things that I've picked up over the last few years that I end up advising a lot of people about when I'm working. So for starters, enable access logs. So this, of course, comes with some cost. So if you want to keep them off and then just enable them when you need them, but have them piped to some sort of log aggregation store that you can use to quickly find out what's going on, because if something really wonky or weird goes on in the internals of the AWS ecosystem, a lot of the time your access logs are going to be the primary thing you have to look at. You should also alert on things that aren't quite as actionable, like rate limiting and concurrent Lambda executions. So if you're not aware, there is a finite number of Lambdas that can execute within your account at any given time. So when I say that these aren't as actionable, what I mean is you can't just fail over and fix this. This is something that is done on an account level, not a regional level. So you should know when you're approaching those limits, and you should have some sort of time to react. Also, create a pre-production or staging environment that matches production as close as possible. This sounds really simple, but when I talk to people, there are those that don't do this. And this will save you not only potentially from a bad deployment, but you can test architectural changes, and very importantly, you can simulate outages. So absolutely go into your environments, be that kind of chaos monkey, simulate outages, remove IAM policy permissions, make things non-existent, and see how your system reacts. You should also aim for simplicity. So you might have noticed that we roll with an active-passive failover implementation. I actually have a lot of reasons that I prefer active-passive over active-active, specifically for serverless. But one of those is definitely going to be aiming for simplicity. This stuff will at times, in a distributed architecture, multi-region, get a little bit complicated. So any place that you can make it simple, it's going to be cleaner in the long run and you're going to be better for it. Remember that serverless isn't a silver bullet, so it's not going to solve all of your problems. It will solve a lot of them, but you'll get some new ones. And also, there's no such thing as no ops, right? We figured that out a couple years ago. So if anybody's coming here thinking serverless is going to take away all of the things that they have to care about from an operational standpoint, that's not necessarily the case. And then finally, use building blocks as they were intended. So each of these is a specially curated product from an industry-leading company built for a very specific purpose. So it is possible to take these things and start stacking them to where they behave a little bit unnaturally, or in a way that wasn't designed by AWS. So embrace the serverless ecosystem and make sure that you're using things as they were intended, and you'll be just fine. And with that, we'll move to Q&A. Anybody have questions?